understanding its password. Its password. Let's do this real quick. I know I've given you guys a whole lot of information. I'm still going to pour a lot of information to you. But if you try to practice them, you'll see it's not that difficult, right? We're using a lot of wordings, but the commands are just simple commands. By the time you do it, it will take you less than a minute or 5 minutes to complete all the commands that we're learning right now. But just for your understanding. Now let's talk a little bit about ITSI password and ITSI group. So when you create a user, or when you create a group, you have some kind of a file system that all this information are being stored. So whenever you create something, it's stored somewhere. Like for example, I showed you when we're creating home, when we're creating users, we're able to, we look at it, we do PWD, right? You'll see that the directory that all that information is stored is in your home, right? So the same thing if you're using ITSI password, it stores information about a user's account and the group. That's what ITSI password and is ITSI group, and it's usually called ITSI, etc. It's called ITSI password or ITSI group. So the ITSI password file is a plain text file that contains information about the user account on the system. Each line in this file represents a single user account. And I would show you what like. So while we're explaining it, let me do this. If I want to cut ITSI password, right? So it gives me this information, right? This is what I want to explain now. First, it has a username. So the user login, right? Then you have this, when you see X here, is the password, right? So modern Linux command doesn't, the old one used to show the hash. You show the hash command, it would give you a password, but it will be an hash form, meaning that it will be encrypted, right? But modern Linux command just gives an X sign, right? So after the password, the next line that you have is the user ID. So every ID that is created, it gives a user ID. You can see C, D, B, A, they all have unique IDs. So these are unique identifications, right? Then the next line is the group ID, right? You can see it's a unique ID, right? They all have unique information. The next line is the user information, right? Which is created in the home/C. All this is created in home-C, right? And the login shell. So the shell that we're using is bin bash shell. It could be a bin sh. So this is when we're talking about the shell that you're using. This is the Linux shell that we're using. Let me see, so I'll get into another topic now, file permissions. I know we touched a little bit on the file permissions, but I think we got ahead of ourselves. Now let's talk about file permissions. That's giving permissions to files. So we talked about first an honor, right? So if I do, for example, LL, right? We talk about an honor. This is an honor of the file. This is the group being the developer. And any other person is others. So you have 3 sections. If it's a file, okay, let me get ahead of myself now. The first dash here means it's a file, right? We don't have any directory here. If we have a directory, you see this will be a D. So for example, let me create a directory. My directory, I call this my directory. So if I do LL again, right? You see this is not a dash anymore, it's a D. So this tells me that this is a directory and it changes, see the color has changed. Let me expand this so you can take a look. Let's do this again. Okay, I think it shows. So this is a D, this is not a file. This is a directory. These are files, right? Now, the first 3.
Actually, you went too fast, though. I'm trying to catch up.
Okay, where did you not
Yeah,
catch up?
My screen resized. Yeah, just go a bit slower. I think I'll get it.
Okay. So what I'm saying is I'm trying to explain what we explained previously. Who is the owner? Who is the group? And who are others? And how Linux represents who is the owner, the group, and others. So take note, the owner, the group, and others. In other words, user, group, and others. So it has, for a file and for a directory, it represents them separately. For a file, it represents with a dash. So if you see any dash, if you do LL or if you do LL-L, right, and you have this format, the first thing that you see here is a dash if it's a file. So for example, we have class 003 file, we have IT file, it starts with a dash. Then I created a directory just to show you the difference. So the only two things that we see here will be, unless we have a symlink, but forget about symlink, we'll get into that. If you have a file or a directory, you see a dash or a D. So that's how this structure starts, right? Then the first three columns here, 1, 2, 3, belongs to the owner or the user. Let's call it the user so we can separate it from others. It's the user. So RWX. R stands for read, W stands for write, X stands for execute. Okay. Then we have next three columns. 1, 2, 3 stands for the group, right? So now the group is read. It doesn't have a write permission, and it has an execute permission. Okay. So you can read and execute or this is a directory. So you can read and execute this directory, but it cannot write into this directory. So the next one is any other person in the world. There are two groups of people. You have the user and the group. This group, right? Then any other person in the world that wants to access this directory has a read and execute permission, right? Read and execute permission. It doesn't have a write, so the person cannot write into it. You can execute this file, but you cannot. You can read any contents from the file, from the directory, but you can execute it if it's an executable or a binary file. You can execute it, but you cannot write. You cannot modify the file. You cannot do anything on the file. You read it as it is, and you can execute it if it's a binary file, right? So those are three groups of people. If it's a directory, it's a D. If it's a file, it's a dash. Is that understood? Or it's complicated? It's going to be a little bit more complicated, but let's start from this one. So let's make sure we understand this.
No, I just didn't see what you were saying before. Sorry. Thank you.
Okay, all right.
Thank you.
Okay, so every other person understands that concept, right? So that's what we are learning right now, the understanding the file permissions, right? So the permissions, let's get to the permissions now. The permissions is read, write, and execute. Read allows viewers viewing the contents of the file or listing the directories. Write allows modifying or deleting the file. So you can modify the file or you can delete the file. Execute allows executing the file as a program. If the script or a binary file, you can execute it. So those are the three permissions: read, write, and execute. Okay. Now let's look at how file permissions are represented and understood in Linux. Okay. I think I explained this already. The first character indicates the file, which is a dash represents a file, and a D represents a directory. The next three characters represent the owner. That's exactly what I explained. 1, 2, 3 represents the owner. The following three characters represents the group. The next three, 1, 2, 3 represents the group. Then the last three characters represent others. 1, 2, 3, right? Represents others. Okay, I'm just repeating what I said previously, right? So here's an example. This is an simple example. So this is a file with a dash RWR, and 1, 2, 3. This one has read permission, and so on and so forth, right? So you have ownership, group, and others. So read and write permission for the owner, read and write permission. read permission only for the group and read permission only for the others. So that's what I'm repeating that, so we should be able to know. So if you see a file system like this, you should know who has the privilege to execute that file, who has the privilege to only read, who has the privilege to read, write, and execute. That's what this means. So not everybody is able to get into a file. There's some files that you create as a DevOps engineer, right, that you only give read permissions to people. There are some group of people that you have to give. For example, if you're developers, you want to give them read, write permissions so they can read, write that file and execute it too, because they want to test the file, right? So if you're creating a file system, you should know how to give those permissions to different groups of people. There are groups of people, for example, like the architects, right? You don't want them to mess around with the code or modify the code. You want them to look at the functions because they designed the system and make sure that the system is designed exactly so they can execute it, but they cannot modify it, right? They can execute it to see if the functions are working well, but they cannot modify, cannot change anything. For them to change anything, they have to go back to the developers to be able to change anything. So those are some use cases. That's why this is important, that you know how to assign permissions to files. So you can change file permissions using the chmod command. So the chmod command you can use, for example, you want to change a file. For example, what file do we have here? You can use the chmod command, right? And with the U, which stands for user, right? You can give that file a read-write permission. Let's put this in practice so you can take a look at it real quick. So for example, I have this file. This file is class 003 file, right? So I want to change permission for this file. It already has, read-write permission, okay? So for example, I want to give it read-write execute permission. So what I do is I sudo chmod, right? U for the user, for this user, this is the user, this is EC2, right? For the user, then I do a plus, I give it read, write, execute permission to that file called class 003, right? So now if I do LL now, take a look at this. Class 003, say I have RWX. Before I only had RW, now I have RWX now. So I've given executable permission to this file now, right? And who am I giving the permission? Is the user. That's why I use U plus the permission, right? Okay. Now we can also do the same thing to a group, right? So if I want to, let me see, this group has, for the class 003 file, the group has a read permission, right? I want to take away this read permission from this group. So what do? I can do sudo chmod, right? For the group, I'm using a minus now, and I want to take away that permission and class 003. Okay, so if I do LL now, right, for the class 00, see, I've taken away all the permission that I had. At least it had one permission, the read permission, but I've taken it away, right? And I can also take away the same permission. I can do the same thing for take away permission for others as well, right? If we do LL now, where is it? For class 003, all the permission is gone for others, right? So you can understanding, there's something else that I need to bring up. No, skip my number here. Okay, so we've understood how the files are arranged, the file systems, and with the chmod command, we can change those file systems like read, write, with a group and with others, we can change that. I think we've discussed that. Now, you can also use numbers, right? Numerically using 3-digit octal base 8 numbers to change permissions. Now, the first permission, read, has a value 4. This comes up in interviews and exams very often, so you take note of this one. Number 4 is read. Number 2 is write. Number execute is 1. So if read is 4, write is 2, execute is 1. If you add read, write, and execute, what's the total value that you have there?
8.
Nope.
No, sorry.
7.
7.
7, right? So if I give someone the value 7, it means that I've given him read, write, execute permission. As simple as that, right? So you add these values to represent the desired permission. For example, give read, write permission to honor, right? Read only to the group and no permissions. So for the honor, I'll give read and write permission, which is 4 and 2, which is 6. I want to give the group read permission only. So I give number 4. Then I don't want to give any permission to any others. So in other words, if I want to change this file name to give read write permission to the honor, only read permission to the group and no permission to others, I'll use 640. Then the file name. So the file that we have in the system is, we have IT file and I have my file. All right, I want to give IT file, right, a read write permission to the honor, read permission to the group, and 0 permission to others. So I will do something like this: sudo chmod 640, right? And the file name is IT file, right? So if I do LL now, right? Where's the IT file? This is IT file. Read write permission for the honor, only read permission for the group, and no other permission to others, right? So the same way that we did plus RW, you can also use numbers as well to give permissions, right? Another example, to give full permission to the honor, read and execute permission to the group, and read only permission to others, you can do something like this, like sudo, right, show mode 751, then my file name is IT file, right? So if I do LL now, right, for IT file, read, write, execute for the honor, read and execute for the group, and execute only for others. So it's a matter of number. The total number is 7. You need to know what read is, you need to know what write is, and you need to know what execute is. If you know these 3 numbers, you can combine them and do your magic, whatever you want to do. And it's much simpler too, right? Any question on this one?
I see.
Yes.
Yeah, so you will chase me from this class with the amount of questions I'm asking.
No, that's
So
fine.
here's my question.
Yeah.
So 5.
Mhm.
So it's the first one is the owner, the middle one is the group, the last one is the, so now 5, 7, 5, 1, right? You can get to 5 2 ways: 4 and 1, 2, 2 and 1, right?
4 and 1 is, no, you can't add, you only add 2 numbers, you don't add 3 numbers.
I see. So it's got to be 4 and 1 to get to that 5.
Yes, it got to be 4 and 1 to get to that 5. You can only add 2 numbers. All right.
Okay.
Question: can we use the numbers to remove privileges?
No, I haven't tried that. I don't think so. If you want to remove a privilege completely, you use 0. right? For example, if we just did show mode 750. Oh, what did I do? Oh, sorry. I did show mode 750, so I can do show mode, right? If I change this to 0, yep, I've changed that permission. So if I do LL now, I've changed the permission. Nothing for that was IT. So if I entered 0, right, for IT file, let's see what do we do again for IT file. So I have 750,
Yeah.
right? So
Yeah,
it's
it's a 0.
yeah, execute now for IT file is only read. What was it before? Did he change it? It didn't seem like
Yeah,
it.
it had a 1 before. It had execute before. Execute is
It had
gone.
execute before. Okay, all right. So now
Yeah.
if we change it to 0, it wiped that out completely, right? So you can use a 0. You can use a 0 or the value 421 to make the changes, right? So in this case, if we want to change the honor to just 4, let's see what it does. We'll do LL, right? IT file. So now it changed 4. It only gives it read, write, execute.
Yeah.
Yeah. It'll
Uh,
be fun if you do 000, wipe everything out. They will all be
yeah,
gone.
let's see. See if I do 000, no one has privilege anymore.
Everything will be gone. Yep. Bam.
So
Empty.
the way this works that it doesn't. Oh, this is IT file that we're looking at. Oh, sorry. I'm looking at my file. I'm like, what is going on? So IT file. Yeah, it
Yeah.
takes out
It's
everything.
been
Yeah,
It,
working.
it
that's good.
It's
works.
been
Yeah,
working
it
the
Looking
whole
at
works.
this
time.
line instead of this line, it wipes
Mm,
everything out.
yeah.
So no privilege, no one can execute. Even the owner
Mm-hmm.
cannot execute this file once you do that. So let's change it back to 751.
What happens if you put a number that doesn't work, like 76? Or 76, it will give 4 and 2.
767, 4 plus 2 is 6. So
Yeah, that's what they will
that will
do.
give you read, write, and um, read and write.
Yeah.
Yeah, I'll give you read and write. All right. So that's how to. Any question on this? It could be confusing too.
No,
So
no more questions. But you brought up something that I've not thought in a long time. Base 8 numbers. Remember base 8 numbers from secondary school or primary
yeah,
school?
yeah.
I
I
have to go look at that again.
yes, best 8 numbers. Yeah, that's how it's coded. If you ask me to get back into best 8, yeah, I need to do some studies about that. I was afraid you're going to ask me a question on that. I said, please don't go there. I know the outer number, the 3 digits, as
That's
way
like
more.
20 plus years ago, if not 30 plus years ago now.
Yeah, so
90.
okay, so that's how to give permissions using numbers, right? And we did this already when you added plus, right? You can add, you use it, remove, you can remove, you can set permissions explicitly using equals to sign. Let's see, I think we have examples here. We did that already when we did the plus. We as a user, we combined it with the plus, add, right? Read, write, and so on and so forth. And you can remove the permission as well. That's the question that Uche was asking, right? Let's see. Numeric representation. So this is what we're talking about, right? Using the 421 to do the representation. Right. This is the same thing. You can change it. So it is an actual file. You can write a script and how to change that script, give permission to that script. You use the same number, show mode, to give those permissions.
Okay, I see.
Yes.
What is this thing about my script? Is it a different? Oh, my script is just a file.
It's a file, yeah.
Like
So
my
like I
file.
said, yeah, you can create any file. So if you write a
Yeah.
script, right? My script, right? Now sh.
Right.
Now you want to execute this file. This is supposed to be an executable file. So you can do sh, right? My script dot sh, right? That should execute whatever file. If you had a script in there, execute that file inside there. That's an executable file. And also there's something else I wanted to show you, that if you have a YAML file, all that files, then you can give permissions to who execute this file, who can only read this file, and so that's what that is. So if I want to give permission to who execute this file, because an executable file, let me sudo vi my script .sh. So I can say sudo cat etc password, right? I can say sudo cat etc group. Right, so I can execute this file. I can say sh, right? My script .sh. See, I've executed this file. So those commands that I put in there, the executable files, I've executed this file. So when I run sh, let me clear this. When I run sh, when I run this command, sh, my script.sh, sh is a shell. I'm using the shell sh bourne shell to execute this file. So I execute once I run this file, it runs those two commands that I have in there. Now I can give people permission. I can give permission sudo show mode, right? 771 my script.sh. So only the people, the owner and the group has all the permissions to run this script. So if you're in a group, if you're a developer, right, and if you're that group, you have the permission. I am the owner too. I'm the user. Being the user, being the owner, I can read, write, and execute this file. Being in that group, DevOps group, which is the second one here, yeah, you can do the same thing, right? But if you are any other person, right, you can only do what? What does one stand for?
One is execute.
You can only execute. You cannot modify this file. You can not change this file, right? So if you are any other person, you're not in the group, you're not the owner, you can execute this file. So that's what one stands for. Does that make sense?
Yes.
What about 7.7?
7.7. What do you mean by 7.7? This to 7.7?
Yeah.
7.7 means I have the read, write, and execute permission, right? So let's
One
get back to it.
you write and execute permission, or it has to be 7.7. Okay, show 1771 my scripts. Okay, I see it.
Okay. So 4 is for read, 2 is execute. I mean to write, 1 is execute. So if I add these 4 numbers and I have value 7, it means I have all the privileges. I can read, I can write, and I can execute. If I only have 1, I only have permission to execute. If I only have 2, I can only write. Right? So that's what that is. It takes a minute to process it. So take your time and do some of the homework. It will come to you very quickly, right? It takes some time to know, yeah, 4, 2,